welcome back to the channel. Alright, we are getting ready to machine the fork disc hub. So this will bolt onto the actual fork disc that we did in the previous episode, and then this will be able to pass through for the shaft that goes up into the support. So this is basically the drive shaft to rotate this disc. So this is a pretty small part. The material is 2x2 by 1 inch thick. We started out with a face and we just polished off the top a little bit, and then we did a boring action with a longer 3/8 end mill so we could go all the way through, and we did it through all the material, the excess material, so that way when we flip it over we had something to probe off of and zero. So and after that we did an adaptive to clear the top section off for the insert to go into the disc, and then did another adaptive to clear around the disc. All this was done with the 3/8 end mill, and then a contour to clean up the top, another contour to clean up down at the bottom, and then we center drilled all 4 of the spots for the screws and did a deep drill, and we almost went through. Actually, we did go through. It was a piercing all the way through, so that we made sure we had enough room for the tap later in the next one. We performed a chamfer routine on the holes and in and out of the bore on the outside edges of the actual part itself. Then we did a tap routine. This is an M6 thread, and we tapped it about 200 thousandths deeper than the actual part. So that was it for that. And then the final was pretty simple. It was there was a lot of material left over, so quite a few passes, and then being that I had this in my really small 3-jaw chuck mounted to the machine, I did a light 10 thousandths finish pass, so I made sure I got a good surface finish on there, and then cleaned it up with a chamfer there and a chamfer on the outer perimeter itself. So we'll go out in the shop and you can see what it looks like. Hey everybody, welcome back to the shop. So today we're making the fork disc hub. We made this in the last episode, and this particular item is the hub that will bolt onto this disc that will allow us to have a set screw and tie it to the main the shaft that supports this entire assembly that it spins on. So we have to make the hub today. So we got the machine on. I got the part already bolted in. The vise was still zeroed from the last operation, so we're going to go ahead and probe this in and get it all lined up, and then we'll start machining. This will be the first half. Once the first half is done, then I will take and put my small, I got a small 3-jaw chuck. I'll put that on there so I can do the remaining surface on there, and then after that we can move on to the next project. So stand by, we'll get this set up and move from there. Alright, we're all set up in the machine. Already have the face mill installed. There's a total of 6 tool changes in here, including that right there for the face mill. So let's get started. I'm going to try to leave this in here. The last episode, the face mill was just covering the camera with spray on the coolant, and this one doesn't have as much to do, so hopefully we'll be all right. Alright, this requires a belt change because we're doing the tapping operation on here, so I'm going to have to move the camera while we do this. So actually I'll just come back whenever I get the belt changed. Okay, we got the belt all changed, and now it's time to do the tapping routine. Alright, that's it. So as you can see, we got the whole hub. Only thing I didn't do was do a chamfer routine on this. I'm not too worried about it. This is where it gets bolted up against the disc anyways. So I at least have the important one to be able to penetrate the hole there, and then potential for the shaft to go right there. So anyways, we'll stop for here, and then I need to set up the jaw chuck on here so I can clamp this in and do the other side. So we'll see you on the next section. Alright, we forgot to set up the camera. I've already bolted my 3-jaw chuck in place, and we're surfacing off the bottom half of the fork disc hub. So we'll get this done. We'll come back, I'll show you what it looks like. Alright, it is all done. Here is the finished surface. As I noted, I didn't index this, so there was no way to put a chamfer on the threaded holes there, but that's okay. But I did chamfer the outside here and chamfered inside the hole. And this hub is to go into the fork disc. So it would be installing from this way. So it's a really nice fit. Wow, look, it even stays in there. So, and then the threaded hole alignment. So yay, now the fork disc hub, I need to drill and tap inside here on the side in 2 places, 90-degree offset from each other. So I got to figure out how I'm going to do that. I don't know if I'll do it on my lathe because I have a drilling fixture to go on my lathe, so I can index it on my lathe and then just cross drill it, versus trying to set it all up and do it on the CNC. It'll take me minutes to do it on the lathe. So anyways, we'll touch base back on whatever we're going to do next. Just hang on. Hey everybody. Alright, so we're going to change this up a little bit. I don't have a spare blade for my bandsaw, so I can't cut a piece of metal that I need to produce another part from the for the ATC. But I happen to have a piece of 5-inch of half-inch aluminum, so I'm going to go ahead and produce a injection mold for the fork retainers. So most people would 3D print the fork retainers, but I happen to have a small injection molding machine that I made quite a few years ago, and I'm going to make a mold for making the fork retainers. This particular machining uses very tiny end mills. I'm using a 1/16 inch end mill, 2-fluted end mill, to machine a majority of this, and then I'll put a couple pilot holes to drill for the pins that'll be for the screws. We'll kind of go over it a little bit once it's all done machining, but we're going to get this going. I'm not going to record a lot of it because it's, you know, it's a fairly big item for a 1/16. It's got some really thin channeling areas, so we'll have to use, you know, a real tiny small end mill. So anyways, we'll come back when we got it done. Alright, so you can see kind of what it looks like on there. It's machining the bottom flange that'll mount up against the aluminum tool fork that we made, and then these are pockets also, and those will be where the screw holes where it'll mount it to the fork itself. So it's still going at it right now. We're 10 minutes into machining. I said it's making it's, you know, width of cut is like 19 thousandths at 10,000 RPMs, and we're machining at 8 inches a minute. All right, voila, it's done. It's a total of 26 minutes to machine this. Like I said, 90% of it was done with a 1/16 inch end mill in a pocketing sequence, and then followed up cutting the sprue with an 1/8 inch ball end mill, and then also drilling, and then I chamfered the edges. So now at this point we just got to part the two. This is 2 halves, so it's got to get parted. These are the alignment dowels that align the 2 plates together, and then I had to drill a pocket or a chamfer, basically a really large chamfer, so that the nozzle on the injection machine can mate up to it, and then the plastic gets pumped in through this sprue right here. So anyways, when we come back, which will be a second for you guys, I'll have a part made. All right, welcome back. All right, so we went ahead and bored this or put our taper in there for our nozzle for the injection machine. The parts go in half like so. These are some brass pins that I machined on the lathe, and those go in, and basically these make the holes for the screws. So it basically creates the void inside the part when it's being injected. And right now I'm using them as the alignment dowels. So you put them 2 together, and then I inject it, and you come up with parts like this. It'll have the sprue on it, but I've already broken the sprue off, so hopefully you can see the part as it is right now. Came out really, really nice. This is made with polypropylene with 30% fiber, so it gives it really strong. I mean, the part itself is basically about 1/8 of an inch in width at the thin area. Actually, it's a little bit less than that. So that's what these look like, and I can make them in seconds, really. As fast as I can get the part out of the mold. My injection machine is a manual machine, so you know the mold is pretty crude, but for low production stuff like that, it's a perfect little machine. So I made these in a matter of just a couple minutes. I made 8 of them. So this is what it looks like with it bolted onto the fork. Never mind the hardware. I haven't ordered hardware yet for any of the ATC projects, so I just happen to have some screws. So it gives it a little springy action, so it'll help snap in the tool. So what we'll do is we'll just grab a tool, and we have one right here. So they slide on like so, and it gives a little snap. And it's very little resistance. I mean, it'll hold the tool up. I'll show you. So it snaps in. See, even bouncing, it doesn't fall out. So that's what it works. That's how it works. So the aluminum helps support the tool much better than just a plastic part. Also, this plastic, all it is acting as a spring clip to hold this in place. That's it. So anyways, that is it. Please like and subscribe, and we'll see you on the next video.